Okay, so good afternoon po. Let's continue the discussion last time regarding working stress analysis. And we have here a sample problem wherein we are required to determine the maximum concrete and steel stresses for the section shown below when it is subjected to a positive moment of 170 kilonewton meter, and we will be using a compressive strength of concrete or FC prime equivalent to 30 megapascal. Okay, let's analyze first the problem. No, kung nasang stage ba tayo? Nakay uncrack stage ba tayo or nakay crack stage? Wala tayong modular ratio n na binigay, di ba? But, meron tayong binigay na FC prime. Pag may binigay na FC prime, we can solve for the value of n. No? At saka sinabi na sa problem, unknown or pinapadetermine natin yung stress ng concrete tsaka steel. At para ma-analyze mo yung stress ng steel, dapat i-consider mo siya sa analysis ninyo. No? At kapag sinasama yung stress ng steel o yung bakal sa analysis, that is under crack stage. No? So let's solve first for the value of modular ratio N. And that is the ratio of the modulus of elasticity in steel with respect to the modulus of elasticity ng concrete. No? For the modulus of elasticity ng steel under pre-stress reinforcement, that is constant, 200,000 megapascal. How about the modulus of elasticity ng concrete? Walang sinabing density ng concrete, therefore, you have to assume that it is a normal weight concrete. So, EC is equivalent to 4,700 square root of FC prime, that is 30, and naka-megapascal. So, cancelled yun. Kindly compute the value of N.
7.77.
8 po.
7.77 and round up to a whole number equivalent to 8. No? Okay, let's analyze the given cross-section. Meron tayong rectangular beam. As you can see, meron tayong reinforcement sa top side and reinforcement sa bottom side. And this is under a doubly reinforced beam. No? Meron tayong given dimension 300 millimeters, yun yung width or breadth of the beam. And from the extreme compression fiber ng concrete to the centroid of steel bars at the compression side, 70 millimeter. And that is the value of D prime or what we call effective concrete covering. No? And the distance of the centroid of the steel bars at the compression side to the centroid of steel bar at the second layer of steel bars at the tension side, 307.5 mm. No, centroid to centroid location ng steel bars sa second layer and first layer ng steel bars sa tension side, 50 mm. And from the centroid of these three bars papuntang extreme tension fiber, 72.5. No, kung i-analyze natin, wala pang binigay na value ng effective depth. Dahil yung definition ng effective depth ay yung distance from the extreme compression fiber ng concrete to the centroid of steel bars at the tension side. No? Yung D. At let's say nandito yung centroid location. No? Hindi natin alam kung nasaan yan. So, from this axis to this centroid of the 5 steel bars, let's say that is y of t yung the notion. No? Actually, meron tayong problem last time na meron tayong dalawang layer ng bakal sa tension side. Kaya lang, parehas yung number ng bakal sa second layer tsaka first layer. That is why, nasa pinakagitna yung centroid ng steel bar. So, kinalahati lang yung centroid to centroid location. But for this one, magkaiba yung bilang ng bakal natin sa bawat layer sa tension side. Therefore, you have to compute where is the location of the centroid of these 5 steel bars. At para ma-compute natin yon, we will be using Varignon's theorem. So, let's draw again yung ating arrangement ng bakal. And then, i-base natin yung location ng centroid with respect sa axis na to. No? And, assume natin ito yung centroid. From this axis, sinabi natin y sub t. No? Centroid to centroid location ng mga bakal, 50 mm. As given in the figure. No? Using Varinion's theorem, that will be the moment of area for the total with respect sa axis na yan equivalent to the summation of moment of area for each layer with respect sa axis na yan. No? Sabi natin A1, Y1 plus A2, Y2. Papansin nyo, yung binigay na diameter for each bars, pare-parehas lang at the tension side. No? Sabihin, kung i-compute natin yung area ng bawat bakal dyan, pare-parehas lang na A. No? So therefore, pag i-analyze natin yung area total, we have 5 A's. No? Multiplied by y sub t, that is unknown. Yun yung distance ng area o distance ng centroid ng limang bakal na to with respect sa axis na to. Equivalent to A1. Let's say yung A1 yun yung area ng mga bakal sa first layer. Sa first layer, meron tayo tatlo. No? Multiplied by Y1. Y1 being the distance of the centroid of this first layer papuntang axis of consideration. No? And that is equivalent to 50 mm. Plus A2. A2, yun yung area ng mga bakal sa second layer. At meron tayong dalawang bakal doon. Multiplied by Y2, yung distance ng centroid ng mga bakal sa second layer papunta sa axis of consideration. And as you can see, yung axis of consideration natin dumadaan sa centroid ng dalawang bakal na yan. Therefore, yung distance nila will be 0. No? So, cancel to. And dividing both side by A, makakancel yung A. Therefore, we can now compute y sub t. Tama? And that is 3 times 50 divided by 5, that is 30 millimeters. No? Therefore, we can now compute for the effective depth. Therefore, effective depth is 70 millimeters plus 307.5 millimeter plus y sub t 30 millimeters. No? And that will give us a total value of 407.5 millimeters. Okay, na-analyze natin yung effective depth. Para ma-compute natin yung stresses ng concrete tsaka steel natin, let's analyze first where is the location of the neutral axis. No, hindi natin alam. Let's say nandyan sa part na to. And, let's say, from the extreme compression fiber ng concrete, papuntang neutral axis, ay a variable of C. Therefore, yung distance ng centroid ng mga bakal sa tension side, papuntang neutral axis ay D minus C, or 407.5 minus C. No? Kapag i-drawing natin yung stress diagram natin, triangular stress distribution din yon. No, ito yung maximum stress ng concrete. Ito yung stress ng tension steel na palaging nakadivide ng N. And, nandito yung stress ng compression steel natin, denoted as Fs prime. At palagi naman yan nakadivide ng 2N. No? So, na-discuss ko na kung bakit nakadivide yung mga yan. Para ma-compensate yung minultiply nating modular ratio values sa cross-sectional area ng steel bars para ma-transform yung mga steel bar na yon, no? Or ma-transform yung cross-section natin. Okay. So, let's analyze C. So, para ma-compute yon, we will take summation of moment of area above the neutral axis equivalent to the moment of area below the neutral axis. No, above the neutral axis muna. Anong area ni ko-consider? Area ng rectangle at saka yung bakal. No? Always take note na yung bakal itra-transform nyo. No? Para maging homogeneous yung section natin. Yung concrete muna, anong area niya? Base times height. Ang base ay 300, ang height ay C. And then, imumoment natin yung area nun, papunta kay neutral axis. So, the moment arm is half of the height. Yung distance ng centroid ng rectangular area papuntang neutral axis. So, that is 300 times C over 2 plus the moment of area of the steel bar above the neutral axis. No? Sabi nga natin, nakamultiply dapat yan ng 2n minus 1. Para matransform natin yung cross-sectional area ng steel bar into an effective area of concrete. Ano ba yung 2n minus 1? That is 2 times 8 minus 1. 16 minus 1 is 15. So, 15. And then, meron tayong tatlong bakal na binigay doon. Ang area ng isang bakal ay pi over 4d squared. Ano ang diameter ng bakal na binigay? 20 mm. So, 20 mm quantity squared multiplied by yung distance ng centroid ng tatlong bakal na yan papunta kay neutral axis. Itong distance na yan. And that distance is C minus D prime. And D prime is 70. So, we will be multiplying C minus 70. Equivalent to the summation of moment of area below the neutral axis. Below the neutral axis, ang i-consider lang natin ay yung bakal. Yung concrete, hindi na. No? So, yung bakal, itra-transform din natin siya into an effective area of concrete by multiplying the value of the area of this steel bar by N. No? Ang N natin ay 8. Meron tayong 5 bakal. And, ang area ng isang bakal ay pi over 4 d squared. Ang diameter na binigay ay 25 mm. So, 25 mm quantity squared multiplied by yung distance ng centroid ng 5 bakal na yan papuntang neutral axis. No, and that is 407.5 minus C. So, 407.5 minus C. No, and as you can see sa equation natin, C lang po yung unknown natin. So, type nyo sa calculator as is, and then shift solve. Kindly compute the value of C.
$156.89.
156.89 millimeters. Store yung value as A para hindi tayo nag-round off. Na? Okay, pagkatapos nyo makuha yung location ng neutral axis, pwede nyo nang i-compute yung moment of inertia at the neutral axis. No? Ano isusolve natin moment of inertia? Yung area above the neutral axis, which is this rectangular section, and then yung bakal, and yung moment of inertia ng bakal below the neutral axis. No? For the concrete first, rectangular section. Itong rectangular section na to, kukunin mo yung moment of inertia niya with respect sa neutral axis. At yung neutral axis nasa base ng rectangular area. Parang ganyan yung shape natin. No? Pag kumukuha tayo ng moment of inertia ng isang rectangular area with respect sa base niya, ang formula palagi nun ay BH cube over 3. Always take note of that. Pero kapag yung axis na kinoconsider ay wala sa base, you need to transform that. Okay, so applying the values in our equation, ang base natin ay 300. Ang height ay C, which is 156.89 raised to 3 over 3. Plus, the moment of inertia ng compression steel with respect kay neutral axis. At meron na tayong na-derive formula dyan. No? So, yung area na yon Naka-multiply ng 2n minus 1. So, ES prime. No? Yung AD squared, transform moment of inertia. Ang gagamitin natin dahil yung IG niya will be considered as negligible. No? So, na-discuss ko na sa inyo last time to. So, area ng steel, naka-multiply ng 2n minus 1 para ma-transform natin. So, that is 2n minus 1 AS prime. And then D, distance ng centroid niya papuntang neutral axis. So, that is C minus D prime. And then, naka-quantity squared. No, palaging ganyan yung formula kapag moment of inertia ng compression steel. No? Kapag tension steel naman, N, AS, multiplied by D minus C quantity squared. Always ganyan yung formula. Para hindi kayo malito, parang nagmo-moment of area lang din kayo. Parang ganyan lang din for the compression steel. Parang ganito lang din for the tension steel. Kaya lang, naka-square po yung last term. Naka-square po yung C minus 70. Naka-square po yung 407.5 minus C. No? So, copy nyo lang as is. That is plus 15 times 3 times pi over 4 times 20 quantity squared. C minus 70 is 156.89 minus 70 raised to 2 plus etong term na to pero naka-square yung last term. That is 8 multiplied by 5 multiplied by pi over 4 multiplied by 25 squared multiplied by 407.5 minus C minus 156.89 quantity squared. So, kindly solve for the value of I and A. Ano po yung mako-compute natin?
Sir, sadya pong malaki.
Yes po.
Ang sagot. 1967.
Parang mali yung 1967.
1726090.
090
852.
852 mm raised to 4. This should be the correct answer po. Parehas lang po ba yung na-compute? Kindly check.
Parehas lang po, sir.
Plus po.
Okay, store natin yung value as B. Pag na-solve natin yung location ng neutral axis, and then yung moment of inertia niya, we can now compute for the stresses. No, stress ng concrete tsaka steel bars natin. At meron na tayong mga derived formula for that. For the concrete first, that is FC equivalent to MC over I and A. No? Ano ba yung moment? Ang moment natin ay binigay as 170 kN meter. So, i-convert lang natin yon into Newton millimeter. So, magmumultiply lang tayo dun ng 1 million or 10 raised to 6. So, yung unit niya magiging Newton mm na. Multiplied by C, that is 156.89 mm over I and A, that is 1726090 852 mm raised to 4. Analyzing the unit, this is mm raised to 4, may natirang dalawa sa baba. So that is Newton per mm squared or megapascal. So kindly solve for the value of FC. Ano po yung sagot natin?
15.45.
15.45.
Okay, and that is in megapascal. First requirement. Second requirement, yung stress ni tension steel. Di ba yung Fs naka-divide ulit ng N? Palagi yon. So, i-cross multiply natin, mapupunta sa numerator. So, naka-N na yon. Multiplied by M, multiplied by D minus C over INA. No? So, ano yung N? That is 8. Moment ay 170 times 10 raised to 6. D minus C, or effective depth minus C. Ang effective depth ay 407.5 minus C, 156.89. Over INA, naka-store kay B. Hindi ko na isusulat yung buong value. Kindly solve, naka-megapascal din po yan.
$197.46.
And that is megapascal. That will be our second requirement. No, last one, the stress of the compression steel, Fs prime. Pag compression steel, naka-prime yung parameters. Kapag tension steel, as is lang, walang prime yung parameters. Ang Fs prime palaging naka-divide ng 2n. So, i-cross multiply mo yun sa kabila, magiging 2n multiplied by the moment. Ang distance ng centroid ng steel bar papuntang neutral axis ay C minus D prime over INA. So, na-discuss na rin natin yan last time. So, substituting the values, 2n is 16. Ang moment ay 170 times 10 raised to 6. C minus D prime is 156.89. Ang D prime, effective concrete covering at the compression side, 70. So that is minus 70 over INA, naka-divide kay B or store kay B. So kindly compute Fs prime.
$136.93.
93. Parehas lang po yung na-compute ng iba?
Opo.
Opo, sir.
Okay. And these are the requirements for this given problem. Yes po, are there any questions? Okay. I think wala. So let's proceed to another one. So for this second problem, we are required to compute the allowable resisting moment of the section shown. We have to assume that the allowable stress ng concrete ay 16 PSI. Ang allowable stress ni tension steel at compression steel bar ay 24,000 PSI. Modular ratio ay binigay equivalent to 9. So analyze the given figure. And wala pa tayong binigay dyan na effective depth. Again, ang effective depth ay distance ng extreme compression fiber ng concrete papunta sa distance o papunta sa centroid location ng tension steel bar. So, what is effective depth? That is 4 plus 16 plus 2. Tama? So, that is 22 inches. At para ma-solve natin yung moment capacity, let's locate first where is the neutral axis. So, assume natin nandyan. Hindi natin alam. And let's say this is C. At pinagpapalagay natin na yung C o yung location ng neutral axis from the extreme compression fiber ay greater than kay 4. So, check natin later on kung greater than 4 ba yung mako-compute nating value ng C. No? Pag hindi, greater than 4, kunyari less than 4 yung na-compute, we need to reanalyze the section. Ibahin natin yung location ng neutral axis. And the location of the centroid of the tension steel bar papuntang neutral axis, D minus C, di ba? Or that is 22 minus C. So, Let's take summation of moment of area above the neutral axis equivalent to the moment of area below the neutral axis. No? So for this one, pwede kayo magdagdag. For the area above the neutral axis, meron tayong T-section for the concrete, di ba? And then yung bakal sa compression side. No, for the concrete, T-section, di ba? Pero yung compute yung area niyan, pero alam nyo ba yung centroid ng isang T-section? Di ba? Medyo mahirap. Pwede yung i-analyze, hati-hati nyo siya. No, hati nyo sa part na to, meron tayong dalawang rectangle. Tama? Or pwede rin naman kayo magdagdag. Dadagdagan mo dyan. So, kunin mo yung moment of inertia ng buong rectangle na to, and then ima-minus natin, or kukunin nyo yung moment of area ng section na to, and then ima-minus natin yung moment of area nung dinagdag nating butas. No? Okay, so either way, either maghati kayo or magdagdag kayo dyan, parehas lang dapat yung mako-compute natin. Mas madali lang po yung analysis kapag nagdagdag. No? So, ibig sabihin yung analysis natin, yung moment of area ng buong rectangle na yan, with respect sa neutral axis na nasa base ng rectangular area na yan, and ima-minus natin yung moment of area ng dalawang butas. Di ba? Okay, papasin nyo yung axis nasa bases. So, madaling i-analyze. So, for this rectangular area, anong area nun? Base times height. Ang base ay 12. Ang height ay C. Ang centroidal location niya papuntang neutral axis ay kalahati ni C. No, minus yung moment of area ng dalawang ito. Pag pinagsama mo yan, rectangular area ulit yan. So, that is base times height. Ano yung base? That is 12 minus the width of the web part, which is equivalent to 3. So, 12 minus 3, ang total base ng dalawang butas na yan ay 9. Ang height nila ay from this point to this point. Ano ba yung height na yan? C minus 4, di ba? This is C. Minus mo lang yung 4. Ang height ng butas ay C minus 4. So, that is the area. And then, imo-moment natin papuntang neutral axis. Yun yung location ng centroid nila papuntang neutral axis. At yun ay kalahati ng height. Kalahati ni C minus 4. No? Yun mismo yung moment of area ng concrete natin. Plus, yung moment of area ng bakal. So, itra-transform natin yung bakal, magmumultiply tayo ng 2n minus 1 dahil nasa compression side. Ano ang 2n minus 1? 2 times 9 minus 1, that is 17. So, 17, ilan yung bakal natin? Isa. Ang area ng isang bakal ay pi over 4d squared. Ang diameter, designation number 9. I-divide nyo yan ng 8 para maging inches yung unit. So, 9 over 8, quantity squared. Multiplied by the moment arm. Yun yung distance ng centroid ng bakal papuntang neutral axis. Ano ba yung distance na yon? From this axis to this axis, that is C minus 2. So, moment arm is C minus 2. Equivalent to the moment of area below the neutral axis. Below the neutral axis, ang i-consider lang natin na yung bakal dahil nasa crack stage tayo. So, yung bakal na yan, itra-transform natin. Mumultiply natin ng n. That is 9. No, meron tayong dalawang bakal. Ang area ng isang bakal ay pi over 4 d squared. Ang diameter, naka-divide ng 8 din. And, multiplied by yung moment arm, yung distance ng centroid ng dalawang yun papuntang neutral axis. And that is 22 minus C. No? So, papansin nyo sa equation, C lang po yung unknown. Type nyo as is sa calculator and then shift solve. What will be the value of C? Ano yung na-compute? Mr. Dalisay? Paki-compute naman. Or yung iba, pag na-compute na ng iba, sabi po. Ano po yung value? Mr. Fortades, na-compute na?
Di pa po.
6.23.
Okay, so that is 6.23 inches. That is the correct answer. I-store nyo yung value as A. Na-compute rin po ba nung iba? Napalabas na yung 6.23? Mukhang matagal tayo mag-solve ha. Anyways, this is the correct answer, no? Naka-store dapat yung value as A. And as you can see, yung inassume nating value ng C dapat ay greater than 4. No? Therefore, greater than 4 yan, correct assumption tayo. No? And after that, pwede na tayo mag-solve ng moment of inertia at the neutral axis. No? Or the value of I and A. Again, ano yung isosolve natin moment of inertia? Yung moment of inertia ng concrete sa itaas, yung moment of inertia ng bakal sa itaas ng neutral axis, at yung moment of inertia ng bakal below the neutral axis. No? For the concrete above the neutral axis, ititreat ulit natin na whole rectangular area to. And then, ima-minus natin yung moment of inertia nung dinagdag nating butas. No? So, ganito ulit yung analysis. And as you can see, yung axis na kinoconsider natin ay nasa base ng rectangular areas. So, kapag kukunin natin moment of inertia nila, that is BH cubed over 3, di ba? That is already a derived formula. Ano yung base ng malaking rectangle? That is a base of 12, di ba? A height of C. So, BH cubed over 3, that is 12 multiplied by 6.23 raised to 3 over 3. Minus yung moment of inertia ng butas na dalawa. BH cubed over 3 din dahil nasa base yung axis na kinoconsider natin. Anong base nila? Ang pinagsamang base ng dalawa ay 12 minus 3 or 9. Ang height ay C minus 4. So this is 9 multiplied by 6.23 minus 4 raised to 3 over 3. So that is now the moment of inertia of the rectangular or the concrete section above the neutral axis. Plus, moment of inertia ng bakal sa above the neutral axis. Sabi ko nga eto, parang ganyan lang din. Tama? Kaya lang, naka-square po yung last terms natin. This is for the moment of inertia ng bakal above the neutral axis, naka-squared lang. And then, ito yung moment of inertia ng bakal below the neutral axis, naka-squared lang yung last term. So, copy as is, 17 multiplied by 1 multiplied by pi over 4 multiplied by 9 over 8, quantity squared. C minus 2 is 6.23 minus 2. Naka-square lang tayo doon. No, plus, the moment of inertia ng tension steel bar below the neutral axis. That is 9 multiplied by 2 multiplied by pi over 4 multiplied by 9 over 8, quantity squared, multiplied by 22 minus 6.23 quantity squared. No? So, kindly solve for the moment of inertia at the neutral axis.
$614.68.
Mali po yung 614.
Five, 6, 8, 6.
Okay, that is the correct answer. 5686.00. Tama ba?
0, 1. Apo, 0, 0.
No, this is inches raised to 4. Store yung value as B. Para hindi tayo nagre-round off. No? Pag na-compute nyo na yung location ng neutral axis, yung moment of inertia niya, po pwede na tayo mag-compute ng unknown. Yung moment capacity na i-resist. No? And that will be based on the allowable stresses ng concrete tsaka steel bars natin. Gamitin muna natin yung formula ni concrete. FC equivalent to MC over INA. No? FC, allowable stress ng concrete binigay sa problem. That is 1,600 PSI. No? That is 16 pounds per square inches equivalent to moment that is unknown multiplied by C, na-compute na natin yan. 6.23 inches, naka-store kay A. Over INA, naka-store kay B, na-compute na. 5686.00 inches raised to 4. So, para ma-compute yung moment, cross-multiply and analyze the unit. So, yung inch na to, mamumultiply ko yung squared, magiging inch cube sa ilalim. Itong inches raised to 4, pupunta sa taas. So, inches raised to 4, divided by inch cube, may natirang isa. So, the unit is inch pounds. I-divide nyo lang po yung value na makukompute by 12,000 para maging feet kips yung unit. So, ano po yung value ni moment?
121.65 po.
Parehas lang po yung na-compute ng iba.
Opo.
Opo, sir.
Okay. Next one. Let's solve the moment value using the allowable stress ng tension steel. Yung Fs. Yung formula na Fs over N multiplied equivalent to M multiplied by D minus C over INA. Ang microphone po, Mr. Fortades. So, substitute the values. Fs, binigay sa problem, equivalent to 24,000 PSI. So, this is 24,000 over N, that is equivalent to 9. Equivalent to moment, which is unknown, multiplied by D minus C. Ang effective depth natin ay 22. Minus C, 6.23. Over INA, naka-store kay B. 5686. Pag cross multiply nyo, inch pounds yung unit na mako-compute. So, i-divide nyo lang yung value na mako-compute by 12,000 para maging feet kips yung unit. Ano po yung moment value natin?
$80.12.
Okay, that is 80.12 feet kips. No. Now, let's compute the moment value using the allowable stress ng compression steel. Dahil meron binigay na value. Fs prime is 24,000 psi. So, ano ba yung formulang Fs prime? That is Fs prime, naka-divide ng 2n, equivalent to moment, multiplied by C minus D prime over INA. No? So, substituting the values, Fs prime, 24,000 psi din, over 2n, 2 times 9, 18. Ang moment that is unknown, C minus D prime is 6.23 minus D prime. Ano ulit yung D prime? Effective concrete covering sa compression side. Yun yung distance ng extreme compression fiber papuntang centroid ng bakal sa compression side. And as you can see here, D prime is equivalent to 2 inches. No? So that is 6.23 minus 2 over INA, that is 5,686. Again, cross multiply, divide nyo ng 12,000 para maging feet kips yung unit. Ano po yung value natin?
$149.28.
Parehas lang po yung na-compute ng iba?
Yes, sir.
Opo, sir.
Okay. So, mapapansin nyo, meron tayong tatlong moment values na na-compute using the allowable stress ng concrete tsaka steel bars natin. Ano yung magiging value ng moment? Ang magiging value ng moment na safe ay yung pinaka-maliit. No? Ito po yung magiging sagot po natin. Moment is 80.12 feet kips. No, so questions po sa sample problem na ito? Any clarifications?
Wala naman po, sir.
Okay, so let's have another problem. Okay. So dito na iba na yung stage natin, no? For this one, we have to determine the cracking moment values given yung mga cross-section below. No? Dito hindi lang nailagay. Let's assume FC prime is 2,000 PSI. No? So, naka-English unit tayo. Cracking moment daw. So, anong formula ng cracking moment? MCR equivalent to FR IG over Y sub T. Pag cracking moment, nakay uncrack stage. Kapag uncrack stage, hindi natin kino-consider yung steel bar sa analysis. Ang kino-consider lang natin ay yung konkreto. No? So, kahit na merong bakal na binigay, iti-take nyo siya na wala. Ang i-analyze lang natin ay yung concrete. No? Okay, let's solve first for the parameters na kailangan for the value of cracking moment. FR first. Anong FR? Modulus of rupture. At yung FR, meron tayong dalawang formula for that. Naka-SI yung isa, naka-English unit yung isa. Since naka-English units tayo, we'll be using FR equivalent to 7.5 lambda square root of FC prime. No? Ang lambda, pag walang binibigay na klase ng concrete sa problem, you have to assume that is normal weight concrete. No, pag normal weight concrete, ang lambda is equivalent to 1.0. No, kaya yung formula nagiging 7.5 square root of FC prime. No? Ang FC prime binigay na sa problem. So that is 7.5 multiplied by square root of 2,000 PSI. What is modulus of rupture or FR? Kindly compute.
335.41.
This is PSI also. No? Okay, meron tayong modulus of rupture. How about I's of G or IG or the centroidal moment of inertia without the consideration of reinforcement? Yung moment of inertia ng concrete section. No? At para ma-compute natin yung moment of inertia ng concrete section, kailangan nating i-locate kung nasan yung centroid location ng ating concrete section. Gross concrete section dahil walang kinoconsider na bakal. And ba yung concrete? Rectangular, di ba? Tama? And nasan ba yung centroid ng isang rectangular? Kahit hindi nyo i-solve, alam nyo na dapat. Ang centroid location ng isang rectangular area ay kalahati ng height. Di ba? So, kalahati ni 21, that is 10.5. Dito sa baba, 10.5 din. No? So, isusolve natin yung moment of inertia with respect sa axis na yan. And di ba pag sinabing moment of inertia na dumadaan sa centroid ng isang rectangular area, ang formula ay BH cube over 12. Di ba? So, IG is equivalent to BH cube over 12. Ang base ay 12. Ang height ay 21 raised to 3 over 12. No? Ano yung formula ng IG or ano yung value ng IG?
1,261.
9,261 po.
Pakiulit po, 1,000?
9,261.
Okay, that is inches raised to 4. Po, pwede nyo rin i-consider yung nasa itaas. No? And then, i-multiply nyo na lang ng 2. Yung moment of inertia ng nasa itaas dahil symmetrical tayo. Kung ano yung moment of inertia nung nasa itaas ng neutral axis, yun din yung moment of inertia nung nasa ilalim. No, dahil parehas lang yung sections natin. Di ba? Pag ganyan, BH cube over 3, di ba? No? If that is the case, that is 2 times BH cube over 3. Ano ba yung base nito? 12. Ano ba yung height nito? 10.5, di ba? 10.5 raised to 3 over 3. No? So, dapat parehas lang tayo 9,261. Do we have the same value?
Opo.
Okay.
Opo, sir.
Maalin man sa dalawang analysis na yan, parehas lang yung mako-compute. Okay. So, y of t, or y's of t, yun yung distance ng centroid ng cross-section natin papuntang extreme tension fiber, papunta sa pinakailalim. So, papansin nyo, y's of t is 10.5. No? Okay, so meron na tayong values nung lahat. Therefore, we can now compute cracking moment. So, FR is 335.41 PSI, pounds per square inches. IG, 9261 inches raised to 4. Over y's of t, that is 10.5 inches. No, analyzing the unit, ito ay magiging inch cube, inch raised to 4 sa taas. Cancelled, may natirang isa. So, that is inch pounds. Again, convert nyo into feet cubes. I-divide nyo yun ng 12,000. Ano po yung value ng cracking moment?
24.65.
24.65.
55.
That is feet cubes. No? For this cross-section. Any questions po? Okay, let's proceed to second one. Okay, ito naman yung cross-section. Yes po, baka may mga katanungan.
Sir, tanong ko lang po sir kung ano pong formula pag SI po yung ano, yung
FR?
modulus of ano nga po yun?
Modulus of rupture. Kapag
Apo.
SI, 0.62 lambda square root of FC prime. Present yan kay NSCP, guys. No, check natin NSCP. Ito yung NSCP, 0.62 lambda square root of FC prime. Pero yung FR na yan, nakabase kay ACI. No? Kaya ng ACI kasi ang formula ay 0.7 square root of FC prime. So, merong modification. No? For a normal weight concrete daw yon yung formulang yan. So, ibig sabihin yung lambda niya ay 1.0 kapag normal weight. So, kapag NSCP, 0.62. Kapag ACI, 0.7. No, syempre, magbe-base tayo kay NSCP dahil yun yung code natin dito sa Pilipinas. No? But, etong formula to, naka-base lang doon sa 0.7 na yun. No? Gets po? May konting revision lang. Ito naman yung formula kapag English unit. That is FR equivalent to 7.5 lambda square root of FC prime. No? So, nasa codes lahat yun. Okay. So, any questions po? Baka may mga clarifications po yung iba din. Okay, let's proceed to another cross-section. Okay. Eto, cracking moment din yung unknown. Still FC prime ay 2,000. Na natin palitan. Kung FC prime ay 2,000, ang FR pa din ay 335.41. No, dali parehas lang naman. Pag nag-iba yung FC prime, mag-iba din FR. So, FR is 7.5 lambda 1.0 square root of FC prime 2,000. This is 335.41. Naka-store na dapat yung value nun. No? And then, MCR is FR IG y sub t. No? Na-compute na natin FR. How about I sub g or IG? Gross moment of inertia or centroidal moment of inertia of the cross-section without the consideration of steel reinforcement. No, so bago nyo ma-solve yan, kailangan nyo i-solve muna yung location ng ating cross-section. O, analyze nyo nga kung nasan yung location. Papansin nyo dyan, nasa kalahati din, di ba? No? This is 15. This is 15. That is not always the case, ha? Dito, kalahati lang din dahil kung ano yung makikita mo sa itaas, yun din mismo yung makikita mo sa ilalim. Parehas mismo yung shape, parehas mismo yung mga dimensions. No, that is why, symmetrical, kakalahatiin lang natin yung height na 30. Pero kung hindi kayo sigurado, pwede nyo namang isolve. No? Let's solve yung location ng centroid natin with respect sa axis na to, sa tension side. No, let's solve natin yung y sub t. Dapat yung y sub t ay 15. Using Varignon's theorem. No, or moment of area. With respect kay axis na dumadaan sa extreme tension fiber ng concrete. Okay, so hatiin lang natin. Hatiin natin dyan. Hatiin natin dito. No? So this is A1. This is A2. This is A3. Tama? And, so that will be, compute muna natin yung A1. A1 is base times height, a base of 12, a height of 4. That is 48 square inches. Area 2 is rectangular din. Area nung web part, a base of 4, a height of 22. So that is 88 square inches. A3 is rectangular ulit, base times height, 12 times 4, 48 square inches. So, area total ay 96, 184 square inches. Tama ba yun?
Opo, sir.
Okay, so using Varignon's theorem, area total, multiplied by yung location niya with respect sa axis na to, location ng centroid niya, that is A1, Y1 plus A2, Y2 plus A3, Y3. Anong area total natin? 184. 184 multiplied by y of t. That is unknown. A1, yung A1 muna, that is 48 square inches. Multiplied by y1, ang y1, yun yung distance ng centroid nitong area na to, papunta sa axis of consideration. Papunta sa axis na yan. So, ano yung distance na yun? Yun ay kalahati ng 42 plus 22 plus 4, that is 28. Plus A2, which is 88 square inches, multiplied by y2. y2 yung distance ng centroid nung A2 papuntang axis of consideration. So, yung centroid location ng A2 ay kalahati ng height, kalahati ng 22. So, from this point to this point ay 11. So, mula dito papunta doon, yun ay a total of 15. 11 plus 4. Plus A3, yun ay 48, multiplied by y3. Yung distance ng location ng centroid na A3 papuntang axis of consideration. And as you can see here, kalahati ni height na 4, which is 2. No? So, solving for y of t, dapat 15 inches lang din daw yan. 15 po ba yung mako-compute dyan?
Opo, sir.
Okay. No? So, kung hindi nyo ma-analyze na symmetrical tayo, you can solve for it pa rin naman. No? So, kung alam mo na kung nasa yung neutral axis, po pwede nating isolve yung centroidal moment of inertia ng cross-section. No? IG. Okay. So, I will present siguro dalawang analysis para makopy yung IG. So, gawin nating hati-hati. So, consider natin area 1, area 2, tsaka area 3. So, for the IG, yun yung moment of inertia ng A1 with respect sa axis na to. Yung moment of inertia ng A2 with respect sa axis na yan. Yung moment of inertia ng A3 with respect sa neutral axis. No? Yung A1 muna. Ito yung A1 eh. Papunta dito sa axis na yan. Di ba wala naman tayong ganyang formula. Ang may formula lang tayo, yung axis dumadaan sa centroid ng area ng rectangle. Or yung axis dumadaan sa base ng rectangle. No? Pero kapag yung axis nandyan, we have to transform the moment of inertia. Kailangan natin location ng centroid niya papuntang neutral axis. So, kung i-analyze natin yun, centroid niya papuntang neutral axis, yun ay kalahati ni 2211 plus kalahati ni 4, that is 13. No? So, transform nyo, centroidal moment of inertia ng rectangular area ay BH cube over 12. Ang base nun ay 12. Ang height ay 4. Raised to 3 over 12. Plus AD squared. Yung area niya, which is 12 times 4 or 48. Yung A1 to. Multiplied by D squared, which is 13 squared. Plus yung moment of inertia nung A2. Papansin yung A2, yung centroid niya nandyan, at yung neutral axis dumadaan sa centroid niya. Di ba pag ganyan, meron na tayong derived formula. That is BH cube over 12. Tama? So, anong base nung A2? Yun ay 4. Anong height nung A2? 22. This is A2. That is raised to 3 over 12. Plus, moment of inertia nung A3 natin. And as you can see, A3 nasa ilalim. No? Yung A3 tsaka A1, symmetrical sila, di ba? Therefore, parehas lang value ng moment of inertia niya with respect sa neutral axis. Pero kung hindi nyo ma-analyze, pwede nyo pa rin i-compute. No? Compute mo yung location ng centroid niya papuntang neutral axis. From this point, papuntang neutral axis, yun ay 13, di ba? No? Dahil 11 plus 2. Kalahati ni 4. So, centroidal moment of inertia, BH cube over 12. Ang base ay 12. Raised to 4 raised to 3 over 12. Plus, yung area niya, which is 48, multiplied by D squared. Ang D ay 13 quantity squared. No, which is, papansin nyo, parehas kay A1. Dahil symmetrical lang sila. So, kindly solve for IG, centroidal moment of inertia of the gross section of the concrete. Ano po yung IG? Yes, Miss Chavez.
19,901.
9,901. Parehas lang po yung
19 po.
iba. 19901.
0.33 po.
19901.33 inches raised to 4. No, that is the correct answer. No, kung ayaw yung analysis na yon, po pwede ito, dagdag bawas method. Ito kasi yung kino-compute yung I section. Moment of inertia niya sa axis na yan. Po pwede yung dagdagan, and then magiging buong rectangle, and then imaminus nyo lang yung moment of inertia ng dalawang dinagdag na rectangle. Diba parang ganyan lang yun? No? Minus yung moment of inertia ng dalawang dinagdag na rectangle. Mapapansin nyo, yung centroid ng mga areas na yan dumadaan sa neutral axis. Kapag ganun yung kinoconsider natin, ang moment of inertia formula ay BH cube over 12. Tama? So, IG will be, eto muna, BH cube over 12 nito. So, ano ba yung base? Ang base ay 12, ang height ay 30. Tama? So, that is 12 times 30 raised to 3 over 12. Minus yung moment of inertia ng dalawang dinagdag nating butas. BH cube over 12 din yan. Dahil yung centroid tsaka yung neutral axis, nag-coincide sila. No? Ano bang base nila? Base nung dalawang butas na yun ay 12 minus 4. That will be their total base. Ang height nila ay 22. So, yun ay 12 minus 4, that is 8. Ang height ay 22 raised to 3 over 12. So, dapat parehas lang daw tayong 19,901.33. Do we have the same value?
Parehas po, sir.
Parehas
No.
po.
So, kung saan kayo na mas nadadalian, okay lang. No, pag na-solve na yung IG, and then YT, solve na din natin, we can now compute for cracking moment. So, substitute lang natin sa formula. Cracking moment, therefore, is FR, na-solve na natin, 335 point, is it 41? Yun, 41 PSI. And then, multiplied by IG, 19,901.33 inches raised to 4. And over y sub t, 15 inches. No? Kung i-analyze yung unit, inch pounds, i-divide nyo ng 12,000 para maging feet kips yung unit ng cracking moment. Ano po yung value natin?
37.08.
Parehas lang po ba yung na-compute ng iba?
Opo,
Opo,
sir.
sir.
Opo.
Opo.
Okay, and this is the requirement for this given cross-section. Any questions po? Okay. Tahimik, I suppose wala. Another cross-section. Again, sabi natin FC prime ay 2,000 ulit. Na-solve nyo na yun, no? FRI, parehas lang 335.41 PSI. No? So, cracking moment, formula ay FR, IG over Y sub T. So, FR meron na tayo. IG. Magbabago yung FR kapag naiba yung FC prime. Pare-paras lang kasi sila kaya pare-paras yung FR nila. So, I sub G or IG, makocompute natin kapag na-locate na natin yung location ng neutral axis. O, analyze nyo nga. Paano natin malolocate yung neutral axis? Symmetrical pa ba tayo?
Opo.
Okay, symmetrical. Therefore, yung neutral axis, kalahati ng height. 27.5 yan, kaya ito ay 13. 27 yun, kaya ito ay 13.5. Ito baba ay 13.5. No? Pero kapag hindi sigurado ka kung nga po, pwedeng isolve using Varignon's theorem. No? So, area total, y sub t equivalent to A1 minus or A1Y1 minus A2Y2. No, bakit minus yung ginawa ko? Dahil ang ititreat nating value ay for the area total, area ng buong rectangle minus yung area ng butas. Ano bang area nito? Malaking ito. That is, ang area nun ay 18 times 27 minus yung area ng butas 6 by 9. No, y sub t is unknown. A1, gawin natin A1 ay yung malaki. No, i-base natin yung yung centroid location lang sa axis na yan. This is y sub t. So A1, so i-consider natin yung area ng malaking rectangle na yan, and that is 18 times 27 multiplied by yung centroid location nun papuntang extreme tension fiber. So that is kalahati ng 27, 13.5. Tama? Minus A2. Ang A2 ay 6 by 9. No? Multiplied by Y2. Yun yung centroid location ng butas papunta kay extreme tension fiber. So that is 9. Kalahati ng 9, 4.5. So that is 13.5 also. No? So dapat Y sub t, makompute natin ay talagang 13.5. Parehas lang ba yung value?
Opo.
Parehas po.
Yes, sir.
Okay. Ganyan yung gagawin nyo kapag hindi nyo sure na symmetrical tayo. No? Pag na-solve nyo na yung location, you can now solve for the gross moment of inertia, IG. O, anong gagawin nyo dyan? Madali lang to. IG, ititreat nyo siya as buo na. I-treat nyo siya as buo. So, solve nyo yung moment of inertia niya doon sa axis na yon. And then, minus nyo yung moment of inertia ng butas. With respect sa axis na yon. O, diba? Pag ganyan, anong formula? BH cube over 12. O, yung malaking rectangle muna, anong
12.
base nun? 18. Anong height nun? 27. Raised to 3 over 12. Minus yung butas. Anong base ng butas? 6. Anong height nun? 9. Raised to 3 over 12. So, what is IG? Kindly compute.
Two 29160 po.
Parehas lang po ba yung na-compute ng iba?
Opo, sir.
Opo, sir.
Store nyo yung value. No? Now, we can compute cracking moment. So, substitute natin lahat. FRI, 335.41. Ang IG, na-compute na as 29160. Over Y sub T, 13.5. Again, inch pounds yan. I-divide nyo ng 12,000 to make it feet kips. Ano po yung value natin?
60.37.
60.37. That is feet kips. So, any questions po sa sample problem na to? Okay, I suppose wala.